All right, one of students, I'm going to try a video solution here. I was asked about number 38 here from this week's assignment, number 18. So it starts off here that says, you used to wish a diverging lens to redirect the laser light from 6 different lasers to produce beams that are parallel to the optical axis. How should you aim the lasers to accomplish this? Well, let me start with the diverging lens. And so the diverging lens we usually draw with kind of this hourglass shape. It doesn't have to be, by the way, something that was curved only one time and then straight on the other. So we often refer to this as a double concave lens, but this as a single concave. We call it concave and plano. Actually, this would do the same thing. And you can kind of get the idea that if I draw the center line, the optical axis, and let me make the ray in red as it comes in, and it would go into the glass, meaning it bends towards the normal, and since it's concaved over, it would be heading outward, away from the optical axis. That's why we call this a diverging lens. And then, because it's curved the other way, it would do it again. This time it would curve away from the normal, and so that would then be even more of a bend outward. So it actually bends twice. A lot of times we just talk about the overall effect of one of them, but that's why something like this, if we drew a optical axis down the middle for each of these, we would get the same effect where it would bend away from the normal, and maybe a hair more, but really very little at this plane surface, and then just head out. So it would be diverging, but not as divergent as that one. And same thing here. The first surface would have no bending, and then it would divert out on the back surface. So since both the front and the back surface contribute to the diversion of the light, then something that looks like this would also diverge it a little bit. In fact, here's kind of the more interesting one to me, is the ones that are bent quite a bit on the, I'll call it the inside surface for a second, and then less of a bend on the outside surface. And this kind of lens we'd call concave convex. But as long as the convex part isn't as bent as much as the concave, you end up with a net diverging effect. So again, if we draw a line down the optical axis, we would hit the first surface, and it would bend outward, diverging. But then it would make it bend back a little bit, but not as much as it diverged out. That's why the curvature in here has to be greater than the curvature in there. And so you still end up with a diverging lens. And that one's probably a little harder to explain and to buy into, but this is how we make glasses. And so if I were to take off my glasses here and kind of show you, it's kind of hard to see, but my glasses are thicker on this end up here than they are in the middle, although I don't think you can kind of tell how thick or lack thereof they are in the middle. You kind of have to really kind of hold it in your hand and feel it, which I didn't want to touch it because then I have to go clean my glasses. So, but these are diverging, and see, I'm nearsighted, so this is a perfect solution for me and my glasses. But anyways, the standard way then of drawing a diverging lens is this way, with a double concave, which really means it's a more diverging than any of these other ones. But this one is nice because it makes the curvature of your face. So this is why we like to make glasses out of this one. So that's why most of the time when we're just kind of learning the physics of it and not really getting into the practicality of, okay, are we going to put where are we going to put this lens without worrying about where to put it and therefore not worried about its shape, this is the kind of the lens we draw. Now, maybe for a little more completeness, I ought to draw a matching one underneath, and so it diverges out, and then so it's exactly the opposite on the other side of this optical axis. Maybe I'll draw two more, this one, and that one, something like that, and then its matching pair on the other side would look like this. But you see this light that's coming in parallel, 1, 2, 3, these 4 parallel beams, are then diverging out. And so this lens is a little harder to understand. It's why I did it second compared to the convex lens or the converging lens, because it bent the light into what we would call a common point, and we called it then a focal point because the light really did converge and go there. This one, we still have what's called a focal point, but we often refer to it as a virtual focal point because on this side of the lens, after the light has gone through, if you trace it back as if it came from a straight line, each of these 4 beams would have the appearance as coming from this spot right here. And so we call it its focal point. Maybe a better word is its virtual focal point because the light never really did converge there. You see, on this type of lens, a converging lens, the light actually did converge at this point. But see, notice what happens after that point. It is spreading out and diverging from it. And so that light has the same appearance as this light as if it came from this point. And so that's why it's called a virtual focal point. It never did actually convert it to a point like it did here, but it still has that same appearance. All right. So maybe I spoke too long already, but I thought I would review and mention a little bit about lenses because here's the crutch of the problem. Light has the same effect forward and backwards. So even though I've drawn it in the forward direction, the reverse direction would be the same thing. And that's how you're going to want to set up these lasers. So you're going to want to set up the lasers shining, so here's laser 1, shining into the lens, pointed at what we would call the virtual focal point. And so I'll take a second laser and point it at the virtual focal point. So the light, if it traveled straight, would hit there, but of course it's going to hit the lens first and go this direction. I'll draw 4 of them real easily. I know this problem says where would you put all 6 of them, so maybe if I had another set of beam here and here, and then I set up in reverse 2 more lasers. But again, the key to the problem and the wording to the problem would be to say set up all 6 lasers so that they point at the virtual focal point of the diverging lens. So that way, before they get to this focal point, so all 6 of them aren't going to meet here, they hit the lens. Now, if you took the lens away, they would all meet at this point. But by putting the lens there, they would then bend the light and they would head out in a parallel direction. And that's the gist of this problem, was to get you to realize how does a diverging lens work, and they work in reverse in the same way as they work in the forward direction. So we talked about diverging lines, and we talked about them in what I'll call the forward direction, starting with parallel light and diverging out. This is saying start with diverging light aimed in, and it'll come out parallel. All right, hope that helps.